A reflection flips the graph of a function across a line such as the x or y axis. Each point on the graph of the reflected function is the same distance from the line of reflection as its corresponding point on the graph of the original function. Here's an example. First, a function f of x. Notice we have a few key points indicated here: 1, 1, 3, 4, and 5, 1. Now if we consider the reflection across the y-axis, when you reflect a graph in the y-axis, the x values change signs and the y values stay the same. So note the points corresponding to 1, 1, 3, 4, and 5, 1. First, negative 1, 1, negative 5, 1, and negative 3, 4. So when you reflect a graph in the x-axis, the x values stay the same and the y values change signs. So again, checking out our corresponding points, the point that corresponds to 1, 1 from the original graph f of x is 1, negative 1 in our reflection across the x-axis. The point corresponding to 3, 4 is 3, negative 4, and the point corresponding to 5, 1 in the reflection, 5, negative 1. For a function f of x, the reflection in the y-axis is f of negative x, so the negative applied to the input x. And the reflection in the x-axis is the negative of f of x. So note here the difference. The negative is applied to the entire function f of x, not just the input values. Problem 3. Reflecting a function algebraically. Let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. What is a function rule for g of x? Consider what you might think on the left and what you may write on the right as you complete the problem. First think, for reflection in the y-axis, change the sign of x. And then you could write g of x equals f of negative x. Then think, evaluate f of negative x and simplify. Well, if g of x equals f of negative x, that's the same as 3 times negative x. Note we're just replacing our old input x with a negative x plus 3. And then simplifying, g of x equals negative 3x plus 3. Finally think, you can check by graphing f of x and g of x for the reflection. Well, graphed here f of x in black and g of x in blue, and sure enough, they reflect across the y-axis. Your turn. Let h of x be the reflection of f of x equals 3x plus 3 in the x-axis. What is a function rule for h of x?